In this video, we're going to practice writing sets in the set builder form. So here are a few answers and I want you to write the questions for these answers. I want you to write these sets in the set builder form. Pause the video, take a few minutes. Okay, so let's do this together. Before we do that, a quick recap. What's the set builder method? Well, this is when you write the question. Suppose you want to write all positive integers less than 6. This is how we write it in the roster form 1, 2, 3, 4 and 5 within brackets and separated by commas. But the way to write this in the set builder method is to figure out what these elements are doing. What are the rules that they're satisfying? So we're looking for the elements that are positive integers and that are less than 6. So if we assume that the element is x, x belongs to the set of positive integers and x is less than 6. In math, this is how you write it. X such that x belongs to natural numbers and x is less than 6. This is the symbol for such that, and the way to bring this all together is have brackets and within that you have x. So we're looking for all x such that x belongs to natural numbers and x is less than 6. So x is satisfying these two rules together. This is your set builder method. Brackets, comma, such that. We have to use all three. Okay, so with this recap, let's go back to our answers and start writing the questions. Let's look at the first one. 3, 6, 9 and 12. What do they have in common? Well, they're all multiples of 3. In fact, they are the first 4 multiples of 3. So we're looking for all x such that x is a multiple of 3, which is x equals to 3n, and this n, because we're looking for first 4 multiples, this n is less than equal to 4. N can only take these 4 values. Also, n is a natural number. So we have these 3 rules that we're satisfying together. X equals to 3n, n can only take natural number values. So n can be 1, 2, 3, 4 and so on. But we're also restricting it. We're saying n has to be less than equal to 4. So this means we're taking the first 4 values. This is how you do it. Let's look at the next one. 2, 4, 8, 16, 32. These are the first 5 powers of 2. 2 to the power 1 is 2. 2 square is 4, 2 cube is 8, 2 to the power 4 is 16 and 2 to the power 5 is 32. So how do we write this? Well, for multiples we use times, 3 times n. For powers we'll use 2 to the power n. So we're looking for all x such that x is equals to 2 to the power n. Here n can take the first 5 values. So let's restrict that. N is less than equal to 5. And let's make sure that n is a natural number. So n belongs to natural numbers. This is how you write this in the set builder form. The next one, we have 5, 25, 125 and 625. These are the first 4 powers of 5. It's very similar to the previous one. We're looking for x such that x equals to 5 to the power n, where n is less than equal to 4 and n belongs to natural numbers. Next one, we have 2, 4, 6 and so on. So we have these even numbers. In fact, we have all even numbers. We have even natural numbers. And the way to do this is, we're looking for all x, where x equals to 2n. We're looking for multiples of 2. So that's why we're using 2n. Here, n belongs to natural numbers and there's no cap. We're not restricting n. We're saying let's take all natural numbers. This is how you get the list that never ends. Then we have 1, 4, 9 and so on up to 100. This is an answer to which question? Well, these are all perfect squares. 1 square, 2 square, 3 square, so on up to 10 square. So we're looking for first 10 perfect squares. First 10 perfect squares. How do we do this? We're looking for all x such that x is a perfect square. X is equals to n square. Here n is a natural number, so n belongs to natural numbers. And we have to restrict n because we're only looking for the first 10 values. So n is less than equal to 10. Alright, the last one. Half, 2/3, 3/4, 4/5, 5/6, 6/7. What's the pattern here? Here the denominator is 1 more than the numerator and we're taking these 6 numerators 1, 2, 3, 4, 5, 6. So this is what we can do here. We're looking for all x such that x is in the form n by n plus 1. So we have taken the numerators as n. The denominators automatically become n plus 1. So this is the form that we're looking for. And what are the values that n can take? N can take these 6 values 1, 2, 3, 4, 5 and 6. So n is less than equal to 6. But to make sure that n takes only these 6 values, we'll have to restrict n to natural numbers. So n belongs to natural numbers. If we don't take n as natural numbers and we only take n is less than equal to 6, n can also take values like 5.5, 2.3 and so on. Because we only want natural numbers, we have to mention that as well. Well, this was a good practice. If you want more such problems, you can visit Khan Academy.